So I do random dithering in order to we have God said 16 color, and so I get more colors. It's kind of I'm a little bit is this it? No. I don't know if this violates the spirit of 16 color. What the heck? Let's anyway. Now the first-person shooter has these are 3D mesh sprites. So if you go in here and you can edit them with the sprite editor. So you pick the mesh you want to edit. Edit mesh. If it's shiftable, that's for that gives an offset for an icon. Anyway, so we can edit the mesh. This is a plant, a potted plant. Anyway, so you can go to I didn't have this before, but now I have edit as text. So this is the vertices and the triangles. The vertices have the XYZ, and the triangles have the vertex numbers and a color. So you could we store them as binary, but you could store them as text now. Then you could do some magic with the text editor. It's okay. I like it as binary. I know it's a major change, but I like them as binary. So if you want to see how they're stored, let's go ahead and copy this home, and we'll play it. Let's copy it to the B drive. Why do I do that? I don't know. B drive is the RAM drive. So now we go to drive B directory star full. Okay, now we want the cluster is number 203. Those are just blocks, by the way. Anyway, so do you want to dump the whole file? Oh, I have a dump command now. I didn't have this before. I think we don't have star. Okay, so there's several sprites in there. Here's the text of the source code, and then there's a 0, and then it's binary for those meshes and other sprites. So is that crazy or what? It's not a very compressed format. Oh well. But however, you know what's cool? We get file compression because it's got a Z. It automatically compresses and decompresses because it ends in .z. This is, the actual size is 5,000 hex, but the storage size is 2,400. So we have compression. So let's go look at that. We can just play it right here. Okay, so we have I'm going to turn the volume down. So 65. So my bucket list was to make a kernel, to make a compiler, to make a first-person shooter, and on my bucket list was to make a flight simulator. Anyway, so I did all of that. It's kind of crappy, but this is an 8-core flight simulator. So it draws triangles. The first-person shooter also draws triangles. Now the map is stored as a sprite in the, it's all in the source code. You don't need resource files. So there's no, well, you could do headers. I guess I should show you an application. So, I don't know, Excalibur. So you're supposed to make a load, which includes, you just include the files, it loads them into memory. A run does a load, and then it starts up, then it calls the main routine, and these go in an app directory. So this has anyway. So I don't like little files. Like, I don't really like. Windows did this. They put all their declarations in one header. Windows did pretty much. So you don't need to include headers because you run just in time, and all the symbols are in a symbol table already. Adam's symbol table. Tasks inherit the symbols of parents, and everybody's a child of Adam. And Adam, when Adam starts, Adam starts compiling. All these includes those headers that I showed you. Adam includes those headers into his table. And then Adam starts including source code. So during boot, we have lots of code that's compiled. So this is all really, really elegant. The command line feeds into a C compiler. So if I say I64 count I64N, I64I, for I equals 1, I lesser or equal n, I plus plus. Printf is just a string by itself. So it compiles incrementally. So if I say unassemble function, or if I say unassemble address count, there's the source code. It compiles it immediately. Now I can say count to 10. Any statement outside of a function executes immediately. A function gets compiled as soon as it's finished and stored in. These are how do I do this? Minus R. So in our local environment symbol table, you can think of it like environment variables. We have count and we have another function. I can say I64I. I just made a global variable, and so the command line feeds into a C compiler function by function, and if it hits a statement 1 plus 2, it compiles it immediately. We got 3. Let's say C trace. This 1 plus 2. That, watch if we say I equals 6. So it assigned to the global variable I. Now if we say I it fetches the global variable I, it puts it in AX, or we can say count to 10. It count to 1. I meant to say count to 10. So we push 10, we call the function, and then we return. So that each task has a symbol table. Each task has a code heap and a data heap. And when it boots, it starts in the bootloader. Starts in the master bootloader. Then it goes to the partition bootloader. Partition bootloader is real mode. And at the bottom of the partition bootloader, it loads the kernel.bin and jumps to it. So we go to the kernel directory. This module goes in the low 640, and the module is compiled with this make. This is the project file. All it is an include of C++ files. These are not headers. These are C files. You don't have a linker. The KStart is they're put in the same order. They're compiled function by function, kind of the same. No, are they? Yeah, they are. Anyway, so this starts in real mode. It calls a couple BIOS routines to change to BGA mode, to get the memory, to get the number of PCI buses. Then it sets up a global descriptor table and changes to protected mode. Then I think it patches the absolute addresses in all the kernel module has 64-bit code. All the code has to be patched. So it patches itself, and it sets up a heap for Adam. Adam is the father of all tasks, like Adam and Eve. Sets up Adam's heap, and we changed to 60. We had to set up the page tables and change to 64-bit mode. We changed to 64-bit mode. We set up the page tables in here. It identity maps everything, so it's just like paging is not used. And then it jumped to the kernel end. This is the main. You could call this the main routine, I guess. Except anyway, so it calls a bunch of initialization, and that it loads the compiler when it gets up and running, and it has. So this is in 64-bit mode. It's not using the BIOS to load the compiler. Then once it has the compiler, it executes the file Atom in the root directory, and so the Atom task is now behaving like a normal task, and it's executing this code. It includes this. By the way, in order to run a task, in order to run a file, you include it. So if I want to say, remember it's going into a C compiler. It's a little, that time's an instruction. It's a long, that's, the instruction took, we have the, we're still tracing the compile output. I'll turn off the compile trace. Anyway, long story short, getting back to Atom, so that when it starts up, this is like your autoexec.bat file. In other words, it's the start of everything. And when it gets done, it goes into your home directory, your account, and it compiles stuff. And all this code is getting placed into memory, just like, you know how we have who minus r. Okay, so we collected a little bit more information. We compiled this a minute ago. So all basic. Now, if you want to see all of Atom's symbols, this is both. These are all the symbols in Adam's table. So we ran out of buffer room. We can say doc max, and then the command line document. Anyway, so now we have all the symbols. So these are all the symbols in the whole operating system. These are, some of them are compiled in, the operating system is 100,000 lines limit. We're at 80,000 lines right now. The kernel is 25,000. It's kernel.bin. The compiler is 20,000. It has an assembler and an unassembler, and a compiler is 20,000. And then Atom is this is compiled during boot. If you want to see it boot, I can do that right now. I'm editing the Atom file, and I'm going to tell it to turn on echo. And now I'm going to do a reboot. Here's my master bootloader. I'm going to boot C. And this is all the code that's compiled by Atom during boot. I tried to do as much as possible. It's only it's about half and half. There's kernel.bin is 30,000, compiler is 20,000, and the Atom directory is another 35,000. Is that what it is? So it compiles on a good in VMware it compiles 100,000 lines a second. So 35,000, well, I guess it takes half a second to compile 35,000. So that's during boot. I'm gonna go turn that off. The reason it's not just echo is because echo is not in the symbol table yet. Echo's not in the symbol table. Anyway, so it's all elegant the way it works. Now Atom, when he's in this boot process, the last thing he does is Atom sys out of your home directory, and if there's not a file in your home directory, it checks the parent, but we do have a file. And this starts up 2 tasks. This causes 2 user tasks. You'll notice when it boots we have 2 terminals. That's controlled by this routine right here. I can get rid of, watch, I'll make it just do 1 terminal. Except, is it going to crash? That would be interesting. Okay, now I'm going to reboot and do, now we have just 1 terminal. So we could do 3 terminals. We could do no terminals. So it initializes the autocomplete. Watch, I think we can disable this. The autocomplete is this window right here. I have a fast reboot that doesn't go to the BIOS. It's a little bit faster. Now we don't have the autocomplete. So the autocomplete lets you jump to source code. It's very nice. That's your anyway. So that's an introduction.